Today's lesson, we're going to be looking at different formulas, maybe like the formula for like area of a square, volume of a cube, stuff like that. And basically, you're going to be solving or transforming a certain formula for a specific variable. So they're going to give you a formula and they're going to say move things around to get h by itself, or whatever variable they say to solve for. Now, today looks weird because it's like the alphabet in one problem, okay? So like look at example 2 down here. Maybe you recognize this formula, maybe you don't, but realistically it's just a lot of different variables and you're just shuffling stuff around to get a certain one alone on one side. Now, you cannot let yourself be intimidated or like thrown off by the fact that there are very little numbers in these problems. You still move things around and you still solve an equation the same, whether you're solving for a variable or not. So check out like this first example here. I am 100% confident that all of you can solve this. So I wrote a note here, it says, think about how you would solve a one-step equation. So if it's like 2b equals 12, and I say, solve this for b, I know that every single one of you would know that you just see that you're multiplying by 2, so you would divide by 2. And then you would tell me that b equals 6. Okay, so you do the inverse or the opposite operation to get whatever it is by itself. Now, formulas, what we're doing today, it's not that different from what we just did here. Okay, the one change, and it's a huge change that throws a lot of people off, but the one change is that some of the numbers in our problems that we're used to now become variables. Okay, so what I mean by that is, let's take that same one-step equation. Here's how it's going to change today. So maybe they would take the 2 and they would replace it with a variable. So maybe they'd call that 2a now. That's going to be the only difference, but they're still going to say, hey, solve this for b, get b by itself. People will get all mixed up because there's now an a in there, but you still think the same thing. Like I still would recognize, okay, I'm multiplying by a. If I want to move a to the other side, I do the opposite, so I would divide by a. And I would cancel the a's. I think the biggest difference is like you can't go to your calculator on a lot of these and like tell me a nice clear number. You just have to leave it the way it looks, because I can't divide 12 and a. I don't know what a is. I don't know what number that represents. So I just leave it. My answer would be b equals 12 over a. Looks awful, but that's the answer. Okay, so moral of the story, you guys, don't let all of the letters throw you off. Okay, so we're just going to do some practice problems. They say solve each formula for the variable that they say to solve for. So on number 1, I want to solve this formula for w. So you can draw your line. Hopefully you don't have to. That shows you what's on each side. This is actually the formula for the volume of a cube, length times width times height. So here's what I would look at. I would see, all right, I want to get w by itself. I need to move the L and I need to move the h to the other side. So I would recognize that I'm multiplying all of those things. So to move stuff to the other side, I need to divide. Realize, you guys, that you can divide by more than one thing at a time. So if you want to move L and h, divide by both of them, because that will cancel both out. Whatever you do to one side, you have to do to the other to keep it balanced. So I've got w is the only thing on the right, which is what I want. This looks really crazy, but that's how I'm going to write my answer. Just leave it v over LH. So if you were to be given the volume and the length and the height of a cube, you could work out this formula to find the width. But in a cube, all the little pieces are the same, so hopefully that wouldn't be hard anyway. All right, number 2. So this formula is slope-intercept form, y equals mx plus b. We'll do a lot with this in a couple units here, but for now, I just want to solve this for m. And if you remember, m represents the slope in this formula. So let's see. if I thought about maybe this equation over here, right here, and I said, okay, if I told you guys to solve this for m, I know you could do this. Y equals mx plus b, that's not that different. So you guys over here, you would say, oh, let's move what's not connected to m first, and you would subtract 4. You do the same idea over here. If I want to get m alone, move the x last that's connected to it. So you want to move the b first by subtracting it, since it's being added on. On the left-hand side, I have y minus b. I can't subtract those, so I just leave it like that. And that's equaling mx. The last step is to move the x, and since you're multiplying, you want to divide by x to cancel that out. Come over to the other side, and you have to divide everything by x. So put that like division line under everything. And then I would just write my answer, again, as awful as that looks, you just leave it, y minus b over x. Okay, example 3 here. So same idea. This is in what's called standard form. So when we do lines, like graphing and stuff, we'll see this. And if they say solve for y, they want you to move it into mx plus b. So I know you're thinking to yourself, this is pointless, I don't need to know any of this. Well, yeah, for future chapters in this class, you absolutely do need to know how to solve something like this for y. So same idea though, I want to get y alone, move the 3 that's connected to it, move that last. So I'm going to move this whole minus 6x term. I can move all of that at the same time. Since it's a negative 6x, I'm going to add 6x to both sides to move that around. So then I would have negative 3y on the left. For the sake of looking ahead, hopefully this doesn't throw you off, but we will be moving into mx plus b. So I'm going to write the 6x first and then the minus 12. You could write minus 12 plus 6x. That's the same thing, you guys. So the last step to get y alone, I'm multiplying it by negative 3, so I need to do the opposite and divide by negative 3. You'd come over to the right and divide everything by negative 3. And I would have y equals. Now, here's what I'm going to show you. You can sometimes reduce these, so you would want to check this out. So watch carefully. You can either write the fraction under everything, or I could break this up, and I could say negative 6, or 6 over negative 3 minus 12 over negative 3. Or you could give each different term its own little divide by negative 3. Basically, you need to be aware of this because I can make this better. Instead of just leaving it 6x minus 12 over negative 3, I can actually divide these two top numbers by negative 3 and come up with an answer of 6 divided by negative 3 is negative 2x. And then negative 12 divided by negative 3 is positive 4. Whoop. So that is the best possible answer. All right, on example 4, and again, this is just like kind of not the same thing over and over, but really I'm just trying to show you that this stuff takes practice. You got to get used to it. So number 4, you got to solve this one for h. So the 3, the m, and the h are all being multiplied. They're all connected. So deal with that last. Move that plus 3 on the end first by subtracting it. So then I would have k minus 3 equals 3mh. Same idea as number 1. If I need to move more than one thing at a time, I can divide by more than one thing. So you want to move the 3 and the m, so divide by both of them on either side. This answer looks awful, but I'm going to keep it k minus 3 over 3m. All right, on the back, I want you guys to try number 5. So this would be another example like number 3, where it's given to you in what's called standard form, and you have to solve it for y, or put it into slope-intercept. And maybe I'm talking crazy when I say slope-intercept and all that. Don't worry about that. That's like 2 units ahead of where we are. I just want you to see if you can get y by itself in this problem. I'm going to finish up the last one, though, and do number 6. This one, I want to solve for q. I hope you recognize that this is a proportion. So if you have a proportion, a fraction equals a fraction, remember that you can cross multiply to get rid of fractions, which is what I would do first, because if it's not fractions, it's going to be a whole lot easier. So if I do cross multiply, I would have m times q equals n times p, which this is so much easier to work with. Now to get q by itself, I just have to move the m to the other side. Since I'm multiplying, I'm going to divide. And my answer would just be q equals np over m. All right, that's formulas.